Hi everybody. In today's video we're gonna be designing a column of this structure using both methods, the required and the provided one. So the first step in our designing process is selecting one column. Let's select this one, for example, and then go to design. From required reinforcement of beams and columns, select code parameters, and from here you can either choose this one or create new one from here. From here choose column, and here buckling with respect to y-axis, member length ly, it should be in axis. That means between axes, or real if you have the real value of that length, you can input it here. Or if there is a coefficient multiply to the original length, you can choose this one. But this time we choose in axis. Then buckling length coefficient. From here, this value can be chosen from here. The buckling scheme representing the column that we have selected is the one that is in this corner. And as you see, we have two ways to identify, we have two ways to specify the desired columns or beams. We have from structure or manual. This time we use manual. And select the column, this one, to see its properties. We see it's this column is CR30 by 70, and its length is 3 meters as shown here. And this beam, sorry, and this beam is BR25 by 50, and its length is 5 meters. You can input it by your hand. Then OK. And here we have buckling length coefficient. Name it as anything. For example, this one. And from here you have additional parameters if you want to change anything, but no need to change anything right now. Then save them and close. Then select the column that you want to apply these parameters on, and then select your parameters, then apply, then close it. Go back to design, and from here go to calculation parameters. From here create new one and name it as column 1. Concrete can be specified from here, but uncheck this one and choose the one that you want, or leave it as it is to choose the default material. If the concrete was lightweight concrete, choose this one, select this one, and specify the percentage of sand. From here we choose grade R, and select the diameter of the reinforcing bars. This time we choose, for example, 18. Cover 5 centimeters. That's enough. And for stirrups, we choose grade R also. Number of reinforcing sections, 3. And type of bars, 10. Number of legs, we make it 4. And inclination 90. That's enough. Then save it. Then select the column that you want to apply these settings to and apply. Go back to design, and from here go to calculations. Loading cases can be specified from here. We have only combination 1, which is ULS, and number of calculation points, we have 3. Then calculate. We go to results. RC design and RC members required reinforcement. From here we have columns. As it's shown here, this is the number of column. These are the details of the reinforcement. Okay. Go back to structure model, geometry. And now we design using the provided reinforcement of RC elements. We select manual combinations and okay. We edit calculation options from here. On standard, from general, um, you want this one to be average reinforcement optimization level, and from here concrete 25, aggregate type it's okay, and from longitudinal reinforcement we want grade R and 18 and 20, and for stirrups we want only 10. Save that as column 1, then okay. After that go to reinforcement pattern and corner bars, they should be auto. Intermediate bars, you have the option to make them the same as corner bars, or you can change them from here. 518 for example, and this one 520. Uncheck this box and all tied. We have here the maximum number of bars in bundles. When we don't have enough spacing between bars, we select this option to make them in bundles. Some codes allow you to make 2, and some of them make allows you to make 3, and the others allow you to make 4. Okay, that's okay. And this is the spacing of stirrups. We select this section, and this one is auto. And from shapes, okay, that's okay, that's enough. Then save it as column 1. And okay. Then calculate from here. As it's shown here, this is the reinforcement details of this column. This is the cross section of this column. We have 4 bars, 4 main bars of 20 in diameter, 20 mm in diameter. Go to RC design, or from story 1, this column, double click it, and you would see the column results. And this is the 3D view of this column. And this is the cross section. And this is the reinforcement table. We have the main and transversal. Well, that was our lesson for today. Thanks for watching. If you have any questions, just write them in the comments below. Bye.